Let me introduce you the panel. Mr. Richard Somberg is going to chair this panel, and then we have Mr. Ravindra Desai from IEEE. Welcome, sir. Please come to the dais. And we have Mr. Phil Bitcher. And another panelist is Mr. N. Murugesan. He is former DG CPRI. Please welcome, sir. And we have Mr. Dinesh Chand Sharma from IEC. Welcome, sir. Please come to the dais. Welcome on dais. Welcome everyone. Now I'll introduce Mr. Ravindra Desai. Mr. Desai is an electrical engineer with over 33 years of experience in industry. He is currently associated with IEEE Standards Association as Global IEEE member. He has led various positions in his career, including working with Alembic Limited as an electrical engineer, and with a Center for Electronics Design and Technology as a design engineer. Mr. Ravindra has also served as a lecturer in electrical engineering at Government Polytechnic in Panji, Goa, and he completed his B in electrical engineering from University of Mumbai in 1984. Some of his top skills include engineering, GMP, and product development. Our next panelist is Phil. We have already introduced him, and thank you for being with us, Mr. Phil. And our next panelist is Mr. N. Murugesan. He has more than 40 years of experience in the area of power system transmission, distribution system, communication protocol and power system, sub-automation, distribution automation, smart grid, advanced metering infrastructure, smart meters, switchgear, testing and certifications, high and low voltage equipments as per national and international standards. He managed one of the largest power engineering research institute as its chief executive officer from March 2010 to 2015, and expanded research and testing facilities to an international level, meeting all IEC and BIS requirements across India and its 7 laboratories. Welcome, sir. Our next panelist is Mr. Dinesh Chand Sharma. Mr. Sharma is associated with European Standardization Project SCSEI as Director Standardization and Public Policy since 2012. Mr. Sharma acts as the focal point in India, representing European Standards Organization, European Commission, and European Free Trade Association. Prior to this, Mr. Sharma worked with Ericsson for 15 years, having last working profile as Director Regulatory Affairs and Industrial Relations. Mr. Sharma began his career in technical customer support back in 1992 and has over 8+ years of industry experience both in India and abroad. Mr. Sharma holds a bachelor degree in electronics business management from the Stanford Institute of USA. Welcome, Mr. Sharma. So now I would hand over this session to the chair of this very interesting session, Smart Energy Standards. So I would request Mr. Richard Somberg to take over the session. Thank you.
Thank you very much for this introduction. And get started, I would like to say a couple of words about how IEC is tackling the challenge of harmonization of standards and the fact that the standards can work all together on the same project, because the standards are developed by many different entities. And actually, we have established system committees within IEC. The purpose being to harmonize and build up consistency between standards developed within IEC and also consistency with standard developed in other standard development organizations. So it's an eye chart. I'm not going to describe all of this. It's just to actually point to the fact that we have been organizing specific processes to tackle this kind of challenge, because the standard development organizations, they are organized in silos, you see. There are 300 technical committees within IEC, and each technical committee might have 20 working groups. That's a huge number of different bodies that have to really be creative, and they are coming up with a new concept, and they are working very hard. But at the end, all their deliverables have to be used jointly in the same industrial projects. So it becomes a real challenge to make sure that they are usable by the industry, that the industry doesn't have to know from where come the standard. The industry wants to have a kind of no-brainer. You see, if you're developing a smart electrification project, you need nowadays to use much more standards than before. And then when you were dealing only with real electrotechnical devices, because now it's a mixture of many different things. And this is a terrible challenge when you're in the industry and that you have to respond to an RFP, and within 3 weeks you have to commit on a technical and financial proposal, and that you have actually to swear that you will comply to a huge list of standards. Okay, so we have organized those processes. We are actually scanning in a recurring manner all the standards we are producing within IEC, and also standards produced by other organizations that might actually be relevant to be used jointly on the same industrial projects. And we are coming up with plans whether to modify existing standards, whether to develop new standards to bridge gaps, and we are developing roadmaps to actually address these specific challenges, and also action plans. And we are actually highlighting a lot of development that we have been achieving in 2022. And just to mention some specific areas that we are investing on is really all these ontology, or you see really reaching some semantic interoperability just beyond just some IT interoperability. You see, the semantic and the ontology is a real new challenge for the smart electrification industry. And also a very interesting concept about the distributed energy resource aggregation business, which it's a full mouth of words, but it's really being able to combine, you see, smart metering with demand-side management and with optimization of generation. It's really coming up with new use cases, embarking actually things that actually the industry and the utilities are looking for. And also, we are coming up with some work on use cases for EV to provide grid support functions, which is very interesting because, of course, it's a byproduct. The EV is, in the first place, is to transport people, but at the same time, you see, there is a huge value, whether to monetize the capability of what EVs can contribute to, or I would say more fundamentally to be able to support the grid, because EVs will actually have a huge impact on electrical infrastructure, especially for the distribution. And I'm skipping this, and just as a last word, let's say for 2023, of course, we still have to re-engage all the communities post-COVID. This is restarting, but there are still efforts to do there. And definitely we're organizing a lot of webinars, face-to-face workshops, and we are organizing direct engagement in between committees developing standards. And we have in place this system committee concept that is really an incubation place for standard development. Meaning that, you see, the traditional way to come up with a new standard development is to have a national committee proposing a new work item proposal, and then a specific committee will start to develop a deliverable on that. But this is where it's interesting to, prior doing that, doing some incubation work, maturing the ideas, and even coming up with some deliverable or pre-deliverable that will allow actually to come up with a much stronger new work item proposal that then actually can, from day one, embark maybe different committees to contribute to the development of that deliverable. In other words, is to build in consistency that will not just pop up by chance. So I invite you, if you have any interest into that, to look into what is in place, and if you want to contribute, of course, BIS, through the presentation of BIS that we've seen, you see, India can fully benefit from that and participate and contribute to that. So now I would like to move forward with 4 presentations that will actually, I think, give relevance to what I introduced, which is really the question of consistency between standards and the usability of a lot of standards in the same project for the industry. And of course, the thing I mentioned about testing and certification, where we have the honor to have a leader here in India for testing with a real experience and incredible labs actually. And of course we have this European Union collaboration where I enjoyed very much your newsletter, what you're publishing in a regular basis, very relevant, very rich. And of course, my old friend and chap, Phil Beecher, is really at the cutting edge of everything about the communication and very efficient OT, I would say OT communication solutions and bridging with IT, which is, you have here on stage, you see, the dream team, you see, to maybe highlight and contribute to come up with the standards much needed to achieve the dreams I have introduced in the previous address. So let's get started, and I would like to invite Ravindra Desai to move forward. If you have a presentation, provided you want to do it from here or you want to go up to the podium, it's up to you. Okay.
I have presentation. ठीक है नहीं ठीक है मैं कर स्क्रीन पे नहीं स्क्रीन पे मैं कर हाँ स्क्रीन पे डाल स्क्रीन Good morning, friends. I am Ravindra Desai.
I am a program manager with IEEE India office. Maybe my profile was old, so my part of ERD, I was heading the high voltage testing at ERDA, that is missing. Anyhow, let me, at the outset, let me thank India Smart Grid Forum and especially Reji Kumar for organizing this very important session or workshop on standardization coordination. As rightly said by Richard, there are so many global and regional standards body. Okay, so they should coordinate. And Richard also mentioned about PM Modi saying it should be one sun, one world, one grid. So similarly, I feel it should be one world, one standard. So that way, I think
that's the word of the day.
Yeah. Thank you. And I thank Richard specifically for sparing his time for this session and taking the initiative for this. And I think we are one step towards this move of one world, one standard. So we have IEEE, we are also one of the standards development body, global standard development body. We have collaboration with many of the standard development bodies like IEC. We have dual logo agreement. We have joint development agreement also with IEC. And in fact, because of paucity of time, I will not show. In fact, one of the presentation I had made on IEEE, ISO, IEC standard. Almost we have 60 plus for your information, Richard. So it's a good achievement that two international global standard development bodies are coming together and developing standards. Okay, 60 plus. It's a good number. We have collaboration with IEC, ISO, and ITU, also with IETF. Okay. So I'll just brief on IEEE standard process. I'll not take more time. Just for the information of the audience, IEEE standard development is very simple. It is two ways or two methods. One is individual. Any group of individuals can come together and they can start developing a standard. Okay, or it's an entity based. So entities can come together, and if they feel there is a need to develop any standard in a particular space, they can come together and develop a standard. Okay, of course, it follows the basic principle of one is due process. So there are specific process to be followed. Okay, then it's open. You need not be a member of IEEE. You need not be a member of IEEE SA. Okay, you can join the group. Okay, then it's a consensus. So for balloting, that should be consensus, and it is not the majority, but 75% of the balloting group should be vote. 75%. In that, also 75% should be in favor of the ballot. So that is how it works. And one more principle is the balance. It is not by one of the group. I mean, there is no monopoly. It is a balance, like manufacturer, producer, user, and the general interest. So it's a balanced group. Okay, and one more beauty of this process is the right to appeal. So if you have any comments on that, you can appeal, whether it is accepted or not. But any comment on the standard has to be resolved. That is the thing. So I will need the help. I'll just go to some of the IEEE standard, and as you know, the buzzword is net zero, or everywhere it is the green energy. Change. So everywhere it is green energy. So 1547, and India has a target of 500 gigawatts by 2030 and net zero by 2070, and it is expected that the energy generation and consumption will be sixfold by the 2047, that is centenary year. Okay. So I will go with 1547, okay, which is a standard on DER grid integration, which is very, very important in this today's world of green energy. So this was first developed in 2003, but there was no voltage regulation, there was no frequency regulation, and the grid is to get disconnected with smallest disturbances. So the new version is 2018, where there is voltage regulation capabilities right through, voltage right through, frequency right through, and earlier there was a limit of 10 megawatts, there is no limit. Okay. There are so many features added to this. I will just go, it's a dedicated series, 1547, dedicated to DER integration. Okay. So US energy policy mandates this for integration of with the grid. So this is mandated by US energy, just for the information of the audience. Okay. And as far as India is concerned, this whole series is under consideration of BS. Okay. This is being reviewed for the adoption for the Indian condition. So see, IEEE, as I was talking of IEEE standards are three types. One is standards which are mandatory. Okay. Then there are recommended practices where IEEE gives their process of what are the recommendation, and third is guide, where it may be used. Okay. So mandate means it shall be, or recommended should be, and guide is maybe. So 1547, the latest version of 2018, it gives a technical specification for testing interconnection and interoperability of utility with the electric power system. Okay. It also provides the requirement for the performance, operation, testing, safety, maintenance of the interconnection, and general requirement like response to abnormal condition, power quality, islanding, and test specification, and requirement design, production, installation, evaluation, commissioning, and periodic test. Okay. So there are different series dedicated to like 1547.1. This talks on the testing. Okay. Like type test, production, commissioning, periodic test, and evaluation. 2 talks on the application guide of how to use this 1547. 3 talks on the information exchange and data control. Okay. I will not go through the detail, but as I said, this is dedicated series. So 1 is on the testing, okay, 2 is on the application, 3 is on the communication and data exchange, 4 is guide for design, operation, and integration of the DER with power system. Okay. This is the recommended practice, 6. And 7, this is guide for conducting the impact studies of DER integration with the EPS. Thank you very much. In case of any queries, You can note down my email, ravindra.desai@ieee.org. Of course, I'm here for any of your queries. Thank you.
Thank you. Thank you very much, because I think you did a great job actually highlighting this iconic series of 1547. That is a real strong foundation, definitely.
Yeah.
Thank you. Thank you very much. And I'd like to invite Dr. Murugesan to share with us his findings, perspective, dreams also, as has been investing a lot and still investing a lot on smart electrification.
Good afternoon, friends. It is a great privilege to have Mr. Richards Schaumburg. He is a chair of IEC Smart Energy Systems. Previously, if you look at it, I will go through that in my presentation. You can see number of IEC committees are involved covering the smart grid framework. Now, with the smart energy as a particular thing comes into picture, all the all the TCs have become part of the smart energy, and he is available here. And whatever smart grid related thing you want to have it, Bible is here, so we can clarify with him. Friends, our smart grid in India, started, when metering automation was, our smart meter development was in this. That was our first thing. We thought that was a great thing to be achieved. Then we went to AMR, then AMI, then again substation automation, and like that started. Then finally we end up in 2008 with that thought that, with the Energy Independence and Security Act 2006, the smart grid concept was planted in the legislation itself. Then the concept like intelligent, wise grid all went off. Finally, the smart grid word came into picture. Mr. Richards, for your kind information, we were the first laboratory to set up smart meter laboratory in Asia in 2004 to propagate in India, and we developed lots of manufacturers to comply with IEC 62056. And again, in 2006, we set up IEC 61850 with the UCA International User Group. Yes, and we developed lots of manufacturers in India, in addition to multinational organizations like Siemens or ABB, like that. So friends, I will go through that very fast. Actually, I used to take the smart grid standardization roadmap for 2 days training, because it comprises of 250 plus standards. So organizer is asking me to complete it in 15 minutes. So I will try to do that. What best we can do that.
If you allow me, actually, I've been told by the organizers that we are globally running late. So I will ask actually all my teammates here on stage to possibly do their best to actually even squeeze the presentation,
I'll
the
do
great
that.
material you have proposed. You know what? You would have a prize of excellence if you do 5 minutes. Try to do it in 10, but I know you were targeting 15, so it's impossible. It's magic, but please help me. Otherwise, the session 2 might be very, very angry with us.
Yeah, no problem.
So-
but you are very.
So bear with me. I might stand up at some point, which might be the signal that maybe we should move on.
Yeah, no problem. I will go very fast.
Go ahead.
So friends, this is agenda. So facing power systems, issue facing power systems, and definition of IEC on smart grid, requirement of smart grid, building blocks. This is very important. The building blocks concept we should be aware of it. And we also talk about NIST standard, then IEC standard, and core standards, and we'll come back to the individual building blocks like generation, transmission, distribution, operation, markets like that. And microgrid, cyber security, storage, prosumer, electric vehicle. Of course, in the afternoon you have a extended session on that. And smart grid for smart meter and AMI and takeaway. So this we are aware of it. What is actually facing in a power system facing the problem. And this is the smart grid definition. That was not available. Now IEC has given a definition of what is smart grid. Smart grid is a term which embraces an enhancement of power grid to accommodate immediate challenges of today and provide a vision for the future power. Its main focus is on increased efficiency, reliability, observability. This is the 3 concepts we need to keep in mind: reliable, efficiency, observability, and controllability of power systems. So friends, the basic thing is that you should have a seamless flow of information. Then only you can have these smart grid systems. Otherwise, when you put a connector, always it is a weak point. So there should be a seamless flow of all the actors. So what are the building blocks? The building blocks are smart transmission systems, EMS systems, advanced distribution management systems, distribution automation, smart substation automation, then distributed energy resources, advanced metering, demand response, smart home, electric storage, e-mobility, condition monitoring, and renewable energy. So friends, who are working on any one of this slot, they should know about what are all the standards concerning this smart grid standards. That is important. So this is the component of smart grids. You can see that, how complex. This is, one second, sorry. So friends, this is the IEC 62357 Smart Grid Standardization Roadmap. It gives complete picture about it. And this is NIST National Institute of Standards and Technology. This is a USA perspective, how various components are interconnected. So friends, as I mentioned that IEC has so many committees covering this smart grid. So IEC TC3, 8 like that. So Mr. Richard is heading all the committee under smart energy. So you can see that so many committees produce standards covering this smart grid framework. You can see that almost 125 out of that, these are all the various committee. And IEC TC57 is very important. Yeah, TC57. You can go through that. So these are all the core standards. There are core standards. These are absolutely essential standards. It's called 62357 reference architecture, 61970, 61850, 61968, and 62351 security related standard, and 62056, which is data, that is your energy meter standards. So like that friends, these are all absolute core standards which is essential. Then comes this bulk generation. If somebody is working on generation like that, these are all the standards which is absolutely you should be aware of it. 61850 is very common because this standard percolates from substation to communication to all the places. Literally, it should go everywhere. It's such a complex standards. Of course, 60870 related series of standards are communication related standards. So these are all the standards related to generation and again transmission. As I mentioned that 61850 is very common, very popular, like that. Well, relay, all such things, it goes like that. And again distribution, again it comes like that. Then operations, these are all the standards are 6196 side or 6190970, whether you talk about distribution management systems or energy management systems. And markets 6235725, it talks about CE fact and so many things, XML, all 5 things are like that. And prosumers, the customer who produces energy, what are the standards governing this particular area. And when it comes to so these are all the building blocks. Somebody is working on microgrid, these are all the standards, IEC standards, which absolutely you should be aware of it. See, as I mentioned, as Mr. Desai mentioned, that 1547 is a very popular standard, which is already integrated into the smart grid standard. Many of the IEEE standards have been integrated into this, IEC standards, including 61850 is born out of EPRI's work, and it became UCI, Utility Communication Architecture 2. Then it became 61850, it is again communication standard. So friends, microgrid standard, the 1547 is very popular here. And cyber security 62351, this is series of standards, and of course NERC CIP standard, which is concerning North America. And of course when it comes to storage, these are all the absolute standards. As I mentioned that you need to have 250 plus standards governing the whole smart grid framework. So somebody is working on smart storage, these are all essential things, these standards you should be completely aware of it. So what are the connecting standards? And electric vehicle, of course, there will be a detailed talk the afternoon. So these are all the standards where even ISO comes into picture. IEC works with ISO, ITU as morning mentioned it. So these are all the standards. And these are all standards governing your smart meter. So I have put some for the benefit of our Indian friends, I have put Indian standards, but it is adoption of 62056, that is IEC standard. There is nothing, there is no different standard, excepting that there is a detection. Tamper detection is here more. That's all we have added there. Otherwise, it is IEC 62056. And smart home, actually it's a big area, but these are all the standard identified for smart grid framework by NIST. NIST book is available, available free of cost. You can download it. Versions are available now. Version 4 is released in 2022 December. You can have a look at it. There they tabulated what are all the standards necessary for keeping your smart grid framework. So friends, I have come to this 5 minutes, I have come to the final stage. This is the takeaway. First and foremost, for smart grid to function in the desired manner is the seamless flow of information among all building blocks. This is very, very important. Otherwise, you will be connecting the connector, that particular portion will become weaker. Time delay, so many things. So there, as far as possible, there should be a seamless flow of information. Only when you have a standard structure, it is possible. Otherwise, it is not possible. Standardized way to make the information flow is ensured. Hence, all the component system needed to follow standard of national international bodies such as BIS, IEC needed to be followed. As a smart grid encompasses more than 200 standards, the user at least be familiar with their particular domain as well as the connecting portion. As I mentioned in the previous slide, where NIST has given so many functional blocks, it has one block has so many connecting network. So you should know that how it is interacting with the various modules. And standard also helps to make full use of life with devices and reduces obsolescence. So friends, this IEC 62357 Smart Grid Standards 2017 is available. It gives a Bible kind of things. It lists out all the standards necessary for all the building blocks. It is a wonderful standard. One standard is sufficient. Now anyway, the version 2 is coming up, that you just keep track of it. And another thing is that this web page, that is IEC Smart Energy, if you see that what all the things are happening on the smart grid development, what are the standards which is going to come up, you will be aware of it. So you will be updated. Anybody working on smart grid has to go through this particular IEC web page to update yourself. And of course, this is the only place where IEC as well as North America is combined together. That example is 61850 is a first class standard where both America as well as European or rest of the world converged. Like that, many standards are coming up. So these are all three things you should keep in mind. Thank you very much.
Thank you very much, Dr. Murugesan. Thank you. You've been doing justice to IEC standards even better than how I would have done it. And I thank you very much for your help to actually help manage the time challenge here for this session. I would like to invite Phil Beecher to actually, if you can actually come up with a substance in 5 minutes, and I know you're able to do that. Let's see.
But I thank Phil for accepting this invite at the last moment. Thank you, Phil. Great to be with you.
Okay, thank you everybody. 5 minutes is a challenge because I like to talk. I only have about 70 slides to go through, so let's see what happens. Basically, I'm going to briefly describe an IEEE standard 2857, which has been adopted by BIS as 18010 Part 4 Section 1. So I'll describe what the technology is briefly. I'll skip over the bit about testing and certification, but anybody that wants to talk with me later about that, more than happy to do so. And then there is one slide on the process by which IEEE worked with BIS to adopt the standard. So the FAN specification is targeting communications for utility networks, and it also relevant to smart cities. It's been developed as a global specification. It was actually initially developed within WISON Alliance, and picking up what Richard said earlier about the value of incubation, we have around 300 member companies in WISON representing 46 countries. I think between 20 and 30 companies were working on this specification for several years, including a number of testing, interop testing events that help you develop the maturity. So the use cases, again, smart metering, connection of DER type equipment and direct load control, as well as relevance to SCADA, but also moving across into other smart city environments. So in many cases, there will be a utility will be responsible for street lighting. So being able to connect smart meter networks and street light networks onto the same communications infrastructure brings value to it. And this FAN network is using IPv6, which means it brings all the benefits of having a multi-service network available. So you don't have to know what communications you want to put over it before you deploy it. So the technology, we don't have time to go into the history. I know Richard said it's not important, but sometimes it brings some value. There was a lot of contentious discussion. The technology was the simple part. The commercial politics was the difficult part in developing all of this. But we ended up with technology that is supported by multiple vendors now. So a bit of an eye chart for the technically minded amongst you. You can see here that this is basically an accumulation of a lot of different open standards from IEEE, from IETF, the Internet Engineering Task Force, as well as a component from ETSI for peer-to-peer security. So it's basically establishing how different standards will work together in a way that means you can test for interoperability. That's the key part of all of this. So I'll skip over the testing and certification part. Within YSUM, we run a testing and certification program. We support conformance and interop testing, and we do this through third-party test labs. Again, I'll make this available to everybody so you can check it later, but 5 minutes is not long enough. We have qualified testing components within our test environment and a number of test lab vendors. We also have an interop demo, which was basically done because there was skepticism amongst the industry whether you can actually get product vendors playing nicely together. So we've proven it can be done. Bit on international standards. In 2008, believe it or not, there was no wireless communication standard supporting peer-to-peer networks for field area networks. There were a whole load of proprietary solutions from, as you can tell, a number of competing vendors. They were all using similar technology, but they were non-interoperable. So there was a standards activity initiated within IEEE 802. I was unlucky enough to chair that activity. After several years, so I went from being young to having been bald with grey hair. But we got there in the end, and we came out with a standard for the communications architecture that was specific to North America and regions using 902 to 928 megahertz. We then extended that standard with 802.15.4u, which supports the India frequency bands, and 4V, which is looking at Southeast Asia, and then some enhancements to security and enhancements to the physical layer for other places. The cool thing about all of this is being developed in a single standards organization makes it very easy for radio vendors and module vendors to develop a single chip and a single module that supports global frequency bands. So I'll skip this as well. There are a whole load of hidden under the silicon is a whole load of different complexity which is actually hidden from view, in the same way that if you have a cell phone, I think you're probably not aware of just how many different modulations, frequency bands are actually existing in that single chip. It's similar for sub-gigahertz peer-to-peer. But we have all of this available from a number of different silicon vendors now. This shows the frequency bands available, but the way this was developed within IEEE 802.15 gives us very great consistency to be able to develop common silicon and a common testing and certification program. So it's very easy to test all of this without it costing a lot of money in test time. So finally, my final slide, believe it or not, the case study, the adoption of the YSUM fan. So Wireless Planning and Coordination Wing in the Department of Telecommunications specified spectrum for 865 to 866 67 megahertz, which was available for IoT applications. We had a number of stakeholders, both Indian companies and international companies, that initiated the IEEE project to amend the 15.4 standard to include this physical layer for the assigned spectrum. And I was lucky enough to chair that, and Mr. Kumar in the front row was technical editor and vice chair. We published that standard in 2016. Again, it had quite a few international participants who were contributing and supporting that. Then Bureau of India's standard adopted that physical layer specification as IS 18010 Part 5 Section 1 in 2020. Then Wi-Sun Alliance worked with IEEE under a liaison agreement to offer the Wi-Sun fan specification within IEEE as 2857. And that was done as an entity-based standard, and again, picking up on what Ravindra mentioned earlier, IEEE is an open standards organization, so anybody participates in this. We had lots of contribution and open discussion. It was adopted as a standard, and then Bureau of India Standards adopted 2857 as IS 18010 Part 4 Section 1 in 2022. So Wi-Sun Alliance will collaborate with BIS and other authorities to deliver a certification program. So thank you, Richard.
We have to thank you. No.
Sorry.
We have to thank you very much, because it's terrible to have you squeezing in such little time an incredible industrial history. I really admire Wi-Sun and the way it's been developed. It's a jewel. And of course, you deserve that I make a special advertisement that you have your exhibitor here.
We are an exhibitor.
So please pay a visit and have a one-on-one tutorial or explanation on all these, because you see it was slide number 34 that has been presented after about 5 minutes. So.
And you can see interoperability in action.
No, that's fantastic, standard. And now we will ask Dinesh Sharma to please share with us also a very exciting initiative, how to team up with different regions. And as I said earlier, he's coming up with very relevant, and he's an effective connector, actually, for a different region in the world. And I will, of course, ask him to help the team here achieve a good time out of the session.
I'll do my best, Phil. On every slide, I will just share one key message so that I could run fast on my slides. Broadly, going back to Richard's comment, when we talk about standard or harmonized standards, we talk about single standard, global standard. Why? Because we need economies of scale. And economies of scale only comes when every product and services are built on a single standard. When it comes to IEC or electrotechnical standard in Europe, through organization called CEN-CENELEC, which basically consolidate all the member states, the national standard organization, to have a single market. To have a single market in Europe, they need to have one European norm. And in case of smart energy, it's almost all of these standards which are implemented in Europe are based on IEC standards, which I'll quickly run through it, because they do not want to reinvent the wheel. Do not reinvent the wheel, do not modify, customize, because achieve what has been done by the expert. And these are the same experts from EU or around the world who sit together and develop these standards. The second comment before I quickly run through my slides is about the interoperability. When you talk about like grid, it became a smart grid. A meter became a smart meter. you put an ICT layer on top of the existing non-ICT infrastructure or non-ICT product and services. The moment you put an ICT layer on top of it, you need to ensure the interoperability of it. And that's what Phil also highlighted. And without interoperability, it does not serve the purpose, which means, again, you need to have the global standard. So effectively, when you talk about standards, it's harmonized with IEC in Europe. But as I was given an opportunity to share what has happened in Europe, how this policy came out and how these standards were implemented, so I can quickly run through with these slides. Some statistics, I mean, the targets which EU has set up, they want to reduce greenhouse gas emission by 40% and increase the use of renewable at least 27% by 2030. And smart grid and smart meter will become an enabler for that. There was also a study carried out in 2019 which talks about that nearly 225 million smart meters for electricity and 51 million for gas will be rolled out by 2024. This number looks small if you compare it with India, but when you see it from a European perspective, it means 77% of European consumer will have a smart meter of electricity and 44% with the gas. So these are some statistics, and you can also see the savings. Savings to the tune of 230 euros for gas and 270 euros for electricity will be saved when you migrate your meter to a smart meter, whether it is gas or meter. Some directive numbers, because in Europe these directives comes out as a legislations, because of which the standards organization need to work on these standards. Some key policy initiative, there is a EU strategy on energy system integrations, which also became a part of European Green Deal, and this strategy was released in July 2020, and which specifically says that various existing and emerging technologies should be implemented, including processes, business model, such as ICT and standard and digitization for smart grid and smart meters. And then there is also an action plan for digitizing the energy system in Europe. So there was a smart grid task force in EU, but now they're renaming it, calling it Smart Energy Expert Group. This is at the Commission level, where they will have the responsibility to align this with their member states. And then there is also a EU-India high-level platform for smart grid, which was done with Florence School of Legislation. The work continues. And now we also have a Trade and Technology Council partnership between EU and India. And as part of that, there will be a green subject will be taken up, which will talk about renewables and the smart energies. Some quick snapshot. It starts with a mandate. Mandate is a request towards standard organizations. Mandate 441, which was released way back in 2009, asked the standards organization to develop a standard. So Sense and Elect together started working on it. These are hyperlinks, which means the first TR was developed for an architecture, then the second phase was delivered. And this is also, there are 4 reports which talks about privacy and security approach, which were released between 2013 and 2016, very important. And then there was also a smart meter coordination group which released minimum security requirement for smart metering. For more details, these are hyperlinks. When you talk about grid, again there was a mandate 490 released in 2011. Smart Grid Coordination Group was established. They published a lot of documentations, but most important was the reference architecture. Apart from other documents. Then this is also a good report which was consolidated to find out what standard exists around the world, whether it is IEC, IEEE, IEC standards. So they consolidated a report called Set of Standards. It was a part 1 and a part 2. It consolidates everything. And then they combined also the meter and the energy, the grid coordination group. Now they call it Smart Energy Coordination Group. This is just a reference architecture, which was SGAM, which was built on the layered architecture, covering all the domains, and which was entire architecture was based on this. This is a report snapshot. If you'll see all the IEC standards mostly are mentions, and even if it is EN, it is an adoption of it. But this reports consolidate all the list of standards which Murugesan sir also highlighted specifically for the grid part of it. These are the new structure of Sense and Like Smart Grid Coordination Group. The last meeting was held in 25th November 2022, but these are 4 working groups which are continuously working on it, updating set of standards, working on the clean energy package part of it, and then privacy and security. ITSE also has a technical committee, I mean, because they talk about smart M2M, which is basically entry point to go and contribute towards this smart grid coordination group. There is also a talk about communication as he highlighted. So there will be a SIM card, which means UICC will be there, and then terminal will also be there. So they also see it more from a metering communication point of view. There are some technical specifications which has been mostly an ontology, but it is based on smart appliances, and then they are also updated for the energy domain part of it. Eco design, quickly some snapshot, because when you see a smart energy, you cannot limit yourself from grid and meter. You have to talk about eco design, you have to talk about energy efficiency, you have to talk about sustainabilities. So there are some hidden slides which also covers the sustainability energy efficiency piece of it, but this is on an eco design point of view. If I conclude, I mean, standards play an important role in implementing smart grid and smart meter project. Digitizing the energy system is a very important action plan in EU, which is continuously working on this modernization of it. This coordination group is continuously focusing on it. And then when you talk about smart energy, as I said, eco design has to be taken care of, interoperability has to be there to achieve the economies of scale, and energy monitoring and management as well. With that, thank you very much. Thanks a lot.
Thank you very much, Dinesh, and I think you really helped. You're a real teammate, and thank you so much. And now it's time for the session 2, focusing on transportation, and which is a very key topic, given the potential for consumption, the potential to contribute to all the key climate change challenges, and also a huge technical potential for the industry. So now the floor is to...
Sorry to interrupt.
Okay, go ahead.
I would request you to come in the middle, so that we want to have a group picture for this session 1, and then we will move to session 2.
Yeah, before that, let me thank Phil. He has rich experience, and to finish in 5 minutes, really very tough task, and he has done that. Thank you.